We classify numbers in many different ways. So, from smallest set to largest set. Well, technically, all of these numbers have an infinite amount of numbers. So, maybe from most specific to least specific. So, from most specific to least specific, they are natural numbers. So, natural numbers are counting numbers. So counting numbers, if you ask people to count, they're going to start with 1. So counting numbers are 1, 2, 3, 4, ... This is called an ellipses, and it means you're just keeping the pattern going. Whole numbers, they're natural numbers plus the number 0. So they're called whole numbers because there is not a negative symbol, there's not a decimal involved, there's not a fraction. So whole numbers are 0, 1, 2, 3, 4, ... Integers are positive and negative whole numbers. So integers are 0, plus or minus 1. So that plus or minus symbol means it can be a positive 1 or a negative 1. It's just a shorthand way of writing it. And then plus or minus 2, plus or minus 3, etc. Rational numbers are numbers that can be expressed as the quotient. So quotient means to divide of two integers. So it's any number. So quotient means divide, so it's any number that you can write as a fraction where you're dividing two integers. So I'm going to give some examples. So some examples are, you could have 1.2, because technically 1.2 is 1 and 2/10 as a mixed number, and you can write that as 12/10, which is the quotient of two integers. It can be negative 1/3. It could be negative 0.6 repeating, because that's negative 2/3. So any number that you can write as a fraction or a decimal that stops. Whereas an irrational number is opposite of rational. So an irrational number is a number that you can't write as the quotient of two integers. So what I think of as rational is something that makes sense. So for example, if you were late for a curfew and your parents grounded you, they probably wouldn't tell you. A rational punishment for that would be the next 2 weeks you can't go out with your friends, or you're going to get your phone taken away for a week. An irrational response to that would be you can never go out with your friends again, or you're going to stay in your room for the next 3 weeks every day after school. That's an irrational punishment. It doesn't make sense. So examples of irrational numbers are like pi, probably already know about that one. The square root of 5, the square root of 7. Sometimes, because if you put those in your calculator, those are decimals that go on forever and they don't make sense. There's not a pattern. Another example of an irrational number would be 1.314,7 ... So this is signifying that this goes on forever, but there's not a pattern right here with this number 3147. And then real numbers are all of the above combined. So a real number is something that you can place on a number line. So if you had a number line 0, 1, -1, you could put in any number on a number line. So real numbers are all of the above. So we can explain the real number system with a diagram. It's just called a Venn diagram. You've probably seen it before. So I'm going to do a similar one to show how it works. So if you have Mars over here, and this is not drawn to size, I'm just showing you with a Venn diagram. This is Earth. So inside Earth, we have the U.S. In the U.S., we have Michigan. And in Michigan, we have Grand Rapids. So this Venn diagram means that everybody who lives in Grand Rapids lives in Michigan, everybody who lives in Michigan lives in the U.S., and everybody who lives in the U.S. lives on Earth. But it's not true that just because you live on Earth, you live in the U.S. Okay, a counterexample could be you could live in China. Or just because you live in the U.S. doesn't mean that you live in Michigan, because you could live in Ohio. But either way, there's two choices here. There's Earth and Mars. You can't live on Earth and Mars at the same time. So that's why in my Venn diagram up here, I have that this is the irrational numbers, and this right here makes up the rational number system. And all of these are part of the real numbers. So the most specific innermost one is the natural numbers, which are also called the counting numbers. Then we back out to integers. Then we go to, oops, I missed that. Then we go to whole numbers, then integers, then rational numbers. So I'm just going to place where these numbers are going to go. So 0 is what is the most specific type of number that 0 can be. I start in, so 0 is not a natural number because natural numbers start with 1. 0 is a whole number. 3/4 is a fraction, so that's automatically a rational number. 6 is a natural number. Pi is irrational, and that looks like a -5, so a -5 is an integer. So name the sets, so name all the sets of numbers each one belongs. So you want to start with the most specific one. So -12 is an integer. That makes it a rational number, which also is a real number. Now I'm going to write this means real, because that notation's used later on in math classes. So I'm just going to use it now. 5/12 is a rational number, and it's also a real number. 3.28 is a decimal that stops, so that is a rational number and also a real number. Pi, if you put pi is a number that can't be expressed as a fraction. The decimals go on forever without a pattern. So this has to be an irrational number, therefore it's a real number. So next part, is each statement true or false? All whole numbers are integers. So think about your Venn diagram. If you are in the whole number system, are you an integer? That's true. That's kind of like if you live in Michigan, then you live in the U.S. And letter B, no fractions are whole numbers. So a fraction is a number that is an integer divided by another integer. So if I write 1/3, that's definitely not a whole number. But what if I write 1/3, what if I write 3/1? Is this a fraction? Yeah. Is it a whole number? If you divide 3 by 1, do you get a whole number? Yeah. So this is actually false. 3/1 is called a counterexample. Another counterexample could be like 8/2, because that's 4. Next part, quick, choose an appropriate number system for each situation below. So give me a number system that could describe that situation. The number of dolphins in the ocean. Well, we know there's some dolphins in the ocean, so this is natural. There's not 0 dolphins in the ocean. The height of a basketball player. So I kind of asked myself, can the height of a basketball player be a fraction? And yes, it can be a fraction, so I'm going to use rational numbers. And to be more specific, since I want to talk about, I don't want to have negative rational numbers, I'm just going to write positive rational numbers. C, the number of pets you have. So can you have a negative pet? No. Can you have a fractional pet? No. So it's either has to be natural whole numbers. I'm going to write whole numbers because you can have 0 pets. The area of a compact disc. Say a compact disc is a CD, so it's a circular shape. So you might know that the area of a circle is pi r squared. So because this pi is in here, it's going to be an irrational number. Okay, next part, an inequality is a comparison of two mathematical expressions. So fill in the inappropriate inequality sign. So which one's greater, -3 or -5? So if on a number line, if this is 0, -3 would be right here and -5 would be right here. So -3 is to the right. So actually, -3 is greater. So you can think of either the alligator situation, or you could look at there's 2 dots on -3 and there's 1 dot on -5. Okay, 1/5 and 2/10. So when we compare fractions, we can compare denominators. So I can change the denominator to 10 right here, and the numerator would be 2. So this would be an equal sign. And then -10.98 and -10.99. Well, on a number line, the negatives, this one would be greater because this one's closer to 0. And then the last one's order from least to greatest and graph on a number line. So what I'm going to do is I'm actually going to turn these all into the same denominators. So what I did is I changed each of the denominators to be 24. So that way I can compare them. So for this one, I had to multiply by 8, the top and the bottom, the numerator and denominator. This one I multiplied by 3, and this one I multiplied by 2. So now if I can put them on a number line right here, this is 0, and you could think about breaking them off into 24s. So this is 1, -1, this is 1. This would be 1/2, which would be 12 24s, -12 24s, and this would be positive 12 24s. So then I could graph -16 24s would be over here, and -15 24s would be right there, and then 2 24s would be right here. So when you put these on a number line, I would change your denominator. So for these, I would change my denominators to a number that 10, 5, and 7 all go into. And then it's easier to write them order from least to greatest. Remember that negatives are always going to go first before the positives, because negatives are less than positives.